welcome everybody. My name is Cepero, and I have the pleasure to be here with you today. Very excited to, to be here and be able to discuss with you real life examples. I think we are at a very important inflection point in the industry, because we are seeing applications that those of us that have been there for, let's say, a couple of years in the industry, we didn't even think that they were possible before. And I would like to guide you today to this type of concept of one data analytics platform that will allow us to collect data, do a lot of different things with the data, but most importantly, this platform should be the one that business should use. So it's not a platform exclusively for IT, but for business. We believe that business should be back in the driver's seat. We believe that the platforms that we create in future should be for business, and we would like to show you a couple of examples on how we do this at A1 Digital with our customers. We are a very small company right now, so it's around almost 200 employees, and we are the digital spin-off of the Telekom Austria Group. The Telekom Austria Group, probably as you know, is like the incumbent telco in Austria, but also has other countries like Slovenia, Croatia, Macedonia, Bulgaria. We are also present in Germany and in Switzerland as well, and Belarus. At the moment, we have our focus is definitely around IoT, machine learning, cloud, and security projects. And we are running at the moment around 500 plus live projects around IoT and other areas. That's the area that I take care of together with machine learning. So when we talk about one platform to rule them all, and obviously if anyone has any information about Lord of the Rings, obviously this is something that we took from Lord of the Rings. So the copyright for that phrase goes back to Tolkien, but also we got some very solid inspiration from BigML. And if you want to know more about that, you need to talk to Paul Peterson. He will show you something very interesting within BigML that alludes as well to Lord of the Rings. So we are all part of this big fan community. But the goal really here is to have one integrated data platform. And normally this integrated data platform should have the ability to ingest sources from different data from different sources, different formats. It should be able to cope with image data, with social media data, IoT data, structured, unstructured data in different volumes at different speeds, time series data. So all of this should be part of the ingestion capabilities of this platform. And then, of course, there are two things in there that are critically important. One is everything related to the enterprise scale reporting and dashboards. Then, obviously, everything related to the ability of business to take that data, put it together, analyze it, derive the right insights. And what we have seen is that more and more the area of machine learning and advanced analytics is something that is really relevant. And that's where we partnered with BigML. And we are one of the partners from BigML, and we allow basically our customers to share insights, predict business outcomes out of those data ingested into the platform. So this, I think, is something that we are obviously building continuously for our customers. We will never be done with this as the requirements continue growing and the complexity of the system continues growing. And what we definitely want to make it very simple for customers, for business customers to consume. Okay, so therefore we are looking at the ability for large data processing and implementations in the cloud. What are the requirements for such a platform that will put the business back on track, back on the driver's seat? So basically, definitely everything related to machine learning, and I think we will go through this within the next couple of days. You will see what topic modeling is, what predictions, classifications, associations, anomaly detections, all the feature engineering capabilities. That's very clear. But also what is important is that the customer has the ability and the business has the ability to discover data. So basically download the data and have it just a preview of what are the key statistical elements in this data. So some sort of descriptive statistics are also important, and that should be something that the business can work with without coding any single line of code. So without writing any single line of code, be it in R or Python or whichever other languages that we all love, business is not capable of doing that normally. So what we definitely would like to have is that intuitive interface that allows no-code drag and drop situations. We believe also that on top of this platform, business applications need to be built, and they need to be built really in a completely abstracted way. So, and all the artifacts of that platform should be exportable and integratable. So whether it's data analytics, algorithms, process, or machine learning models, all of them need to be able to be exportable, integratable, and at the very, very granular level, because that's the prerequisite for building very feature-rich abstracted applications for the business. Okay, so that the business doesn't need to code and depend on IT or depend on a data scientist or depend on things that they don't have under control. Now, on the infrastructural side, obviously, in order to do that, the complete infrastructure needs to be integration ready and API first. And what that means is that every single element in this infrastructure has to be addressable via an API, so that an application can steer and control what happens at a granular level. And obviously, if we don't want to have IT involved here from the very, very, very beginning to the very, very, very end, we need to have a zero install, auto-scalable, auto-deployable type of infrastructure. As we at A1 Digital are also providers of cloud infrastructure, public cloud, edge cloud infrastructure, we have taken a lot of dedicated time to make sure that our platform, specifically when we incorporate BigML, is here the foundation for this auto-scalable and auto-deployable. So we basically want to have a one-click deployment of platforms for our clients. And obviously, now that I talked about auto-scalable, you would see that that's where Sauron says hello, because that's basically the auto-scalable cloud infrastructure from BigML as well. It goes without saying that all of this has to be in a secure environment. The data has to be secure, and you should have the ability to anonymize and pseudonymize the data if needed be. You don't always need that, but if needed be, you should be able to include synthetic data as well. So this is kind of the very, very complex requirements of this type of platform, and this is what we believe it's going to be very, very difficult in future to replicate and to build. From as a sort of a cookie cutter approach, one size fits all. We believe this is going to be very, very, very difficult. So far, so good. The next topic is we are discussing. We have delivered multiple projects in different line of businesses, and I would like to show you basically how this works from our perspective, the type of projects we do. It goes from line of business HR, supply chain management, marketing, controlling, but also it goes into different industries like construction, waste management, energy. In public sector, we've done a couple of projects as well. And it's always what we enjoy a lot is having this type of the opportunity to have different tools for different use cases, and also the opportunity to combine them so that we can solve new use cases that even the customers didn't see at the beginning. And so this kind of partnership between customers and us, as a service provider, that's super important for us moving forward. So what we are looking at is the delivering projects in different industries, and this is what I was talking about, different line of business topics, but also multiply that into different industries, and then you have the right tool set to do that. So without spending much time on this, these are just key examples of what we've done so far. Very interesting project around call center resource planning, sales monitoring, revenue monitoring as well, predictive maintenance, very classic, machine learning for energy trading, and then topics around churn prediction. But I want to focus today on three major deep dive examples that I would like to take you through, and then so that we can have a discussion later on. The first example would be, this is the example of energy trading. We're talking about the tertiary energy markets, and what we do is we're helping the customers balance the energy in those markets. What it means is you have a lot of energy generation capacity, wind, solar, but all of this is not something that you can control properly. So at the end of the day, you need to balance when there is an oversupply of capacity of generation, or there is a surplus demand and there is not enough demand. So you need to shut down and switch on different energy generation capacities. And for that, there is a market price, and there is a price at the initial market, the primary market, secondary market, and we are the tertiary market helping customers balance that energy pool. So it's a very complex thing, but the interesting thing here is, how do you do this if you don't know what the price would be tomorrow? And you need to bid for tomorrow for a specific time frame. So tomorrow, for let's say from 8 o'clock till 10 o'clock, I want to have certain I want to provide certain capacity to that pool. So how do you put a price for this? How do you build the price for this type of things? It's a very complex scenario, and we use here machine learning to show to help customers doing that. So customers were doing this before in a very manual way. So manual means they were really spending their time on Excel sheets, trying to balance and understand what happened in the past. And what we did is we built predictions for them. So we built this type of application that shows, okay, for a specific time slot, what were the historic prices, what will be the predicting prices, and you're seeing right now the almost real-time predictions. This is what we did for them, and this is today. So yesterday, excuse me. So it's until yesterday. You see here the predictions for today. So in the different time slots, what will be the energy price, the price for providing that energy in this time slot. And then we provided also basically an average of daily prices so that they can understand what will be the next level. So this type of applications, this is something that the business runs without writing a line of code. It's a business application or HTML as a front end with very nice graphics. So the customers, they don't see anything in the back end. They don't have to touch any IT infrastructure, any IT scenario. We just build the application for them, and they trade day in, day out on this tertiary markets for energy. This is something that we completely automated. So basically, data is ingested from the source. Data is also ingested from the market, and the algorithms, they work in a very solid way. It's a simple algorithm. It's not very complicated, but yet it shows what kind of applications can be built for business and putting business really on the driver's seat. That's the most important thing. So no IT interactions here, no database, no coding, no R, no Python, nothing. It's just an automated machine learning platform in the back end. That's BigML, and then this type of applications on top. The next thing that I would like to show you is it goes into retail, and retail is a very interesting industry. Here we're doing something very special, which is we're creating a model for cannibalization and retail analytics. What it means is you have different promotions. For example, you say today this type of product, let's say a specific meat product will be 20% cheaper, and you send the pricing calculations, the new pricing, you send the new pricing to the retailers, so to the point of sales. So down there they will change the prices, and tomorrow the meat will be 20%. This type of meat will be 20% cheaper. The problem with that is that yes, you do this, but your revenue in this specific category of meat may go up, but your profitability in the overall category, meat category, could go down, and could go down really dramatically. So in order to do that, you need to have a prediction of how your overall profitability, your overall revenues will evolve depending on which market it is, which kind of consumer group it is, where is this market located, what is the temperature out there. So there are a lot of factors that will play into this one. And we can build very complex models here, but the most important point that I wanted to show you is not the complex models, but more that now that you have this type of multivariable analytics here, you need to take care of the model itself. And this is something that at the moment, very few applications out there take care of the model. So we take care of the deterioration of the model performance. We take care of what we call model drift. That means there is a back-end, like a back-end part of this application that takes care of the health check of these models, so that you know that the model is continuously delivering what it needs to deliver. And in order for that, you look at the predictions. How have the predictions been deteriorating in the past? And the way that you do that is that you understand, you do a forecast basically ahead. And you say, what is the percentage of products that will be correctly predicted by this model? So we use here machine learning for machine learning, if you wish. In this specific case, what you see on the right is in blue, you see the predictions, the error rate of the model currently in use. And in yellow, you see the prediction, the error rate of the model that of a new model that is much better, that is better, the model that we are testing right now. So now imagine for this that you have one model that is currently live, and then you may have 5 or 10 or 600 different candidates in the backend working with the same data, but having different hyperparameters. And with that, that allows you to have always a sort of a survival strategy for the best. It's almost like an evolution game where you play. You have multiple models, one of them is live, the others are running in the backend, and as they run in the backend, you know what is the best model, and then you switch the live model from you take it down and put that model which delivers the best predictions for the next time range. And this is what we can see here. We also check the anomaly of the data, so making sure that the data, if it's anomalous data, we detect it early enough. Yeah. So this is examples of another application where, again, here, although it's much more complex than the previous one, the business still has the ability of looking at the models and changing them as well without spending time in coding and infrastructure. The third example is about rail transportation. So this is more of an IoT example. And what we do here is we do something very interesting, which is detecting flat wheel conditions. What is a flat wheel condition? Basically, if you look at this train of this rail wagon here, you see the rail, the wheels. And it could be that for whatever reason, the brake of the train has not released properly. So the brake continues pressing while the train will get in motion, pulled by the locomotive in the next couple of minutes. Now, if this condition persists, even if you don't believe it, believe me, the locomotive can pull a complete wagon with the brakes on, because the power is too hard. So what happens then is you will have flat wheel conditions here. So basically, the wheel will flatten over the course of the through friction, and this is something that you need to detect. So what did we do here? We created a sensor. We put a sensor on the wagon. The sensor detects vibration, and we hoped that through this vibration that we detect and the GPS signal and acceleration, we are able then to detect that condition. But how do we do this? I mean, we cannot send these things into the cloud. This is something that we need to do really very locally. So all the analytics or the main analytics needs to happen in this specific device here that is put on the train. So the way we did this is to take a chip, an accelerometer chip with a computational block in there, and we put a decision tree in here, and we applied BigML capabilities for creating, first and foremost, a model. And that model got imported and got evaluated, obviously, and got imported from here. So we took data, test data from real devices. put it into the BigML modeling tool, got the decision tree for that, imported that into what we call TinyML. So we are combining TinyML and BigML together. We send this then through the IoT platform into the device, and now this device has this decision tree here and can start detecting all these things locally, and it will send obviously the warning back to the IoT platform, and then there will be a warning saying, okay, there is a flat spot for wagon 12405, probability 93%, and we've seen this alarm 12 times. Now, the really cool thing here is that we use, in this case, a major platform in the cloud to create models and transport them into local edge type of sensors, and the data coming from those sensors will enrich the model again, and so we have an increase in precision and prediction capabilities from those sensors, right? So what we did basically was create a system in which data remains mainly in the devices. There is no need for high energy consumption, and even if there is limited cellular connectivity, the alarms will continue being created, and once you have cellular connectivity again, then data will be sent back to the platform. So this is basically how the journey for this TinyML would look like. So from scoping to validation, it takes approximately 12 weeks for us to create something like this, and obviously this is a work in progress. We continue creating more and more higher precision with better labeling, the sizing of the models is better. Test deployment will be very critical in the next couple of weeks, and this is what we do for our customers. So in summary, I just wanted to show you three very concrete examples. The first one, energy trading, which is a pure application. The second one is basically when we talk about the ability to take this cannibalization process, the cannibalization tendencies in retail and analyze them and avoid them. And the third one was a pure IoT play with TinyML and BigML together. So basically downsizing models so they can fit on a chip and using that locality for detecting immediate changes in the acceleration, and imply from here that we have a flat wheel detection, a flat wheel situation that we can detect. So these were the three things. What we would like to do in future is, and we'll be announcing that probably next week. Now that we are in the phase of this COVID, fighting COVID and fighting the coronavirus, we want to make sure that we can support research organizations that are researching around impact of corona, being it on the medical side or on the economic side. And if there is a research organization that would like to have access to the platform, to BigML, in Europe, we can provide that basically on our cloud platform. That's what we will be announcing this probably in the next couple of days. So stay tuned for that. Thank you very much for your attention.